Alright, Nicholas, please.
Okay, so hello everybody. We're gonna be starting our first scheduled workshop exactly an hour late. So this will be the iOS development with Swift and SwiftUI workshop that we have here. It is going to last, I'm not sure how long, but let's start off with Swift and SwiftUI. We're gonna start off with Swift language fundamentals.
And I'll talk you through a to-do list app in SwiftUI.
Yeah, we're gonna do a demo app of a to-do list. So here we go. We're gonna dive right in.
All right.
Yeah. Okay. So here is a brief tour of the Swift programming language. So have any of you coded in Swift before? No? Yes? Yay, okay. Wait, so have any of you done iOS? No, not iOS.
No.
Xcode development? No?
No.
Okay. So let's go ahead and do a brief tour of the language itself. So these are some general operators in the language. This is just for reference, so if you want, we can have the slide back. But first of all, we're just gonna go to the next slide, and also that's a TODO. So Java is the language that is taught at this institution for their intro CS course. So let's go ahead and see how we define 4 different types of values here. So we have number, integer. But this is so in Java, the value type goes before the variable name, and then you just assign it to a value. So I believe all of us is taking CSE 140X, I think. Okay.
Yeah.
All right. So let's just go ahead and move right on to Swift. So in Swift, all variables you have to have this var keyword. You have to have this var keyword. They are a variable. If it's a constant, it will be a let. The equivalent in Java will be static final.
Yes.
Okay. And right here followed by the variable name. And now this is the variable type, as you can see here. And it is separated by a column between the variable name and the type. And then in the end, we go ahead and just assign it to a value. And the other thing about Swift is that it has type inference. So you don't have to declare its value type, unlike Java. So I can say var number equals 3. It's automatically going to assume that by 3 I mean an integer. But if I go ahead and do double, oh, it's gonna know that's a double. And right here, if I say emoji equals true, then it's gonna automatically know, hey, true is a boolean. I'm gonna set this to a boolean. So this is type inference in Swift. And then we have some string concatenation stuff here. So in Java, I believe in CSE 142 and 143, they didn't teach how to have strings as a variable in Java. But in Swift, how you would do it is if you have a string here, you have another string, and well, you can actually just do this plus this. What?
Yeah, go ahead.
Yeah, you can do just this plus this, you know, the way with the 142 and 143 is teaching it. However, I believe Java you can also do that, but I'm not entirely sure what this school's course is teaching. But in Swift, if you want a search string, you can just go ahead and do a string here, and you can just fill out wherever you want this string to be with this slash, parentheses, the variable name. So what this will print out, not print out. What does she do? Okay, so fruit.pen. So it's going to replace that with apple and that with pen. So it's going to replace exactly where that is with the variable, the string of the variable name. So let's go ahead and go fruit equals pineapple. Okay, so here we reassign the variable fruit to the string pineapple. And now we print a string, and this is a variable pen plus this fruit. So basically, wherever this is present, you replace it with the string that this variable is referring to. Or you can just do string plus, you know, the way that 143 and 142 was teaching it, which also works. And that's his face, I guess. So this is a standard for loop in Java. You have a starting integer, you have a condition, and you have an incrementation. Not increment, an action that it does every single iteration. In Swift, a loop will look something like this. It will be for I in the starting index minus not starting index inclusive and index uninclusive exclusive. Right. So next up we have Java. Yep, this is a similar for loop, but instead of going up, it goes down. In Swift, it will be something like this. For I in start to end, you just put reverse. It's a building function called reversed. But okay, this I believe this has not been taught in 142 or 143. But basically, what it's trying to do is it defined a starting, which is a double, and then the condition, and then you can increment it not by integer because it's a double. You can increment whatever increment you want. And then in Swift, it wouldn't be like this actually. This is deprecated, so it is currently this in stripe from the starting index to the end index by increment. And the I is a double in this case. Okay. Function and method. So we're gonna go ahead and talk about function and method. Oh my god, turn this up a bit. Function and method. Now this is kind of messy. So I'm just gonna. Should I just show them that? Okay, I'm just gonna. Okay. This is kind of messy, so I'm just gonna go ahead and skip to. Yeah, right here. So, a function in Swift is defined by the func keyword, and this is the function name. Oh, a function is in Swift is a method in Java because it's an encapsulation of a bunch of code that executes a particular task. So we have the func keyword, we have the name of the function, we have the name of the argument. Ignore this for now. We have the name of the argument, and then and then the type of the argument, which is the same way how we would declare a variable. Right here, this is what it returns. Now it is important to know that all these things means the same thing because void means the same as this, and if it's returning nothing, you can just have nothing here. This is the body of the function itself. Now what this underscore thing does is, I'm just gonna go ahead and go to the next slide. This underscore thing does.
Go back.
Okay. Whoa. Okay. Yeah, no wrong. Yeah. So what this underscore thing does? Because in Swift, if you have a function that's intaking a parameter, it will be like this. So this parameter is called 2. Is what is that?
That's argument label.
Yeah.
2 is the argument.
Where's the name? Is this
list is the parameter name.
List is the parameter name. What did you do?
What?
Isn't this supposed to
So alright.
This omits the name.
Yes, this omits the argument label. Down there's an example of that. So okay, I'll take this slide. So in Swift, the calling argument methods are actually a little different. You will have something called argument label. Is you add it in front of the parameter you are passing in. So for example, here we are adding an object to an array. In this case, this reads rather smoothly in English. To achieve that effect, we can use an underbar to indicate we don't want any argument label for this first parameter. So when you call it, you just say add object. But for the list variable, we have a 2 as the argument label. That's why we need to say add object to array. That way we indicate you are doing that.
I think what you did here, this is a name, right?
That's argument label. That's parameter name.
You set the type as an in-out.
Yes. So in-out is rather interesting in Swift because you can actually change any reference to pass in or a value passing. In Java, you can't do swap to int with a method, but in Swift, you can do that with in-out parameter. You just add an ampersand in front. It's kind of like C++ pointers. You can manipulate that way. And any just says you can be any element to store.
Okay. Default value. Wait, what did you put the default?
Yeah,
Oh god, what did I do?
a function as parameter, but that's okay.
Completion equals nil. Boop. Boop. So, why Swift? Well, what else? What other language? Actually, you can use that. You can use React Native, but no. But this is mainly comparing Swift between Objective-C and Java, though.
Yeah.
Should I talk about Swift compared to like React and?
Sure, you can talk about that.
Okay, so first we follow the slide and we look at Java. So I mean Java. I guess we couldn't really blame Java for this because Java is generally known to be a hassle just to print out hello world. Like many languages, Swift, for example, Swift and Python included, not C, it's just print hello world. Yeah, so again we can so that's pretty simple way of printing out stuff. Objective-C is the old probably programming language for the Xcode development, but it was replaced in 24. Not replaced. It was Swift was introduced in 2014. So before that, it was all Objective-C. But right now it's 2019, so I guess we wouldn't talk about Objective-C that much. Expressions Java versus Swift. So right here we have a difference between creating a new instance of a class between Java and Swift. So what is the key here is that Swift has. This is not just for creating a new class. This is the same for functions. If you don't put the lower score thing. So if you don't put a lower score thing, any functions, any word that requires parameters, you have to have the name and then its value. And the name
the argument label.
Yeah, and also if you're developing it in Xcode, it's gonna fill all of this out for you. So you don't actually have to remember what the name is. So it gives you a nice reminder. Where are we at? Java versus Swift. Let L equals to mutating, non-mutating. Okay, so here we have a string in Java, and then we have string down to uppercase, and does this mutate the string? No, right? No, it returns a new string. It returns a new string, right?
Yes.
Or it returns a new string.
You see, that's the problem with Java.
Yeah. So that is the thing with Java. Now for right down here is Swift. So L equals array dot sorted. So this sorts the array, but it returns it to a new array, and the array itself doesn't change. However, if we call array dot sort, it sorts the array itself and it changes and it just returns it. Okay. So that is quite clear. But strict. Alright, so go to.
That's a statement you say. You don't have
yeah. So one thing that I have to mention is I don't think there are many languages that doesn't implicitly do the type conversions. For example, Swift, for example, Python. Java's not one of them. So I just feel this is a very handy thing, especially when you're trying to concatenate multiple variables together. Because the reason that Java doesn't have this is the only reason why there is 10 points worth of expression questions on the CSE 142 midterm /final. Like in any other language, that part wouldn't have been possible because it either wouldn't compile or wouldn't run. So you can't. Anytime you want to do concatenation of any sort, you have to specify what type the value is, because it will never try to guess what value is, and then you end up in Java like concatenating random stuff together. Type of variable can be changed after declaration. Well, this is unless you do any.
Yes.
Yeah.
You're still of type any though. You don't change your promise type.
Yeah. Oh yeah, it's still of type any. That's right. That is right. Okay, so this is quite handy too. Optional. So Swift being a development language, it has this system called optional, which is that if a variable can be a no. You have to declare it as an optional variable. Now, what happened here is that the explanation mark here is what we call forced unwrapping. So what it means is doesn't matter if it's a no or nil or not. Just give me the value. This is forced unwrapping. So this is typically only used when you know that the value is not going to be nil. But most of the time it wouldn't be nil. So I guess that's good. Safe/strict error handling. Yeah, this is just a general error handling code. Let's see. What is the useful stuff? So one thing I do have to mention about the device Swift part is in mobile software development, you can, there's often many ways to do it. For example, the way that we are running our workshops today is we have native solutions, which is Xcode and Android Studio. That's what is commonly referred to as native solutions because you're building them separately on the IDEs and frameworks provided by the makers of the software itself. There are cross-platform solutions, such as React Native, which is React Native is mostly designed to be building web mobile apps because it's basically built in a way that allows web developers to make their web into a mobile version of the app, and that's React Native. That is cross-platform. Something else is called Flutter, and that is also cross-platform. It's off a what language is Flutter on? Apollo.
Dart.
What?
Dart.
Dart.
Dart. Yeah. Dart.
Okay.
But they have some trouble with lists. They don't have self-reuse, so your list is very slow. You have many elements in it.
So that's the other thing that you can do cross-platform, and then if you're developing like things like games, I guess you have like all the game engines, Unity, Unreal, they can all build cross-platform. So, but one of the things with cross-platform is, I think a common thing that's usually said about cross-platform is if you draw a graph of where the X is project complexity and Y is effort required. If you use native solution, it's a linear growth. If you use non-native solutions, it's often an exponential growth. So what will usually happen is, if you have a linear function and an exponential function, for the initial part before they intersect, the exponential is going to be lower than linear, which means that in that sweet spot, cross-platform is probably better. And in that sweet spot, what it usually is a web version of a website on mobile. But after you get past the intersection, after you get to like complicated stuff like machine learning, you want to use like AR on the device, you want to use on-device capabilities, you want to interact very closely with device hardware, then cross-platform grows exponentially while the other one grows linearly. So that is what I guess what we stand about this subject is that if you're in that sweet spot, if you're trying to turn your website into a web app that doesn't necessarily interact with the hardware on that complex of a level, if you get a sweet spot, cross-platform is quite nice because there's less effort required. But if you want to go deeper into your project, especially if initially you release it, it might be in that sweet spot, and as you build it up, it might get more and more complex, and then maybe you'll find out that to a point where you kind of have to rebuild it in native solutions. So, I guess for games it's different because if you're using a game engine, it's always going to be that game engine. So that's the other thing. So I would say that that's the general thing for non-game applications. That's the thing about native development, and that's the thing we're doing today because we have both separate Xcode and Android Studio. So you can develop for the entire family of softwares. There's no TV up here, but also develop for TV. That's Linux. Yeah, so Swift also does run on Linux and also web for a certain purposes. And compiler. There's much more compilers. Now, if you search online, you can probably find one. But this is Swift fundamentals and the reasons of using Swift in mobile development.
All right. So one thing I would like to mention before we move on is Swift on Linux. You can actually have a web server written in Swift. And there are many things in native Swift right now, so you should give it a try if you're interested. And now let's move on to the second half of our presentation. Is we'll write a to-do list app with Swift UI. So let's first look at what the to-do list app should look like. Here we have an iPhone simulator. If you haven't downloaded Xcode, you should do that now. Yeah. All right, so this is a reminder app. On the top, we have a name of your list. So you can add stuff to your reminder, like, hello, this is to-do list. And you can mark things off. You can delete them as you wish. And that's basically, and you can edit the to-do list item after you added it. So we're going to build something similar to that. This is what we're going to be building today. So you also have the same functionality. You can check, uncheck. You can add a new to-do list item to it. You can delete them. You can bulk edit. And so first thing we should do is have Xcode. What we're going to do is we'll create a new Xcode project. We'll select single view application. So here we have a product name. Why don't we call it to-do list app? And then here the team, you don't, possibly you have none as your team, but if you have Apple account, you can do that. Organization name, you can just do your own name or thing you want. Organization identifier is your personal domain, but if you don't have one, it's totally fine. You can do like, my name is Apollo, uw.edu. So what we do is reverse this. And that's our organization identifier. The language is Swift. The user interface is SwiftUI. Make sure you select SwiftUI because otherwise you have storyboard. That's not what we want. You can uncheck all of those. And let's click next. We can just save it anywhere on your Mac. You don't need to create a Git and don't add it to any workspace. And we'll create our new project. So this is the procedure we'll follow for today. So first we have all the features planned out, what we're gonna need for our to-do list app. And now we have seen our UI design, but let's start with the simple stuff. So when you have this, you should have both things on the sides. Can you see my... Yeah, we'll have a presentation light. Okay, now we can properly see this. On your screen on the left is your code editor, and on the right you have a preview. Click the resume button on the right, and you'll see hello world, hopefully soon. All right, hello world. And now when you change something there, you'll actually see a real-time preview on the right. Now let's look at how our to-do list app should look like. To-do list app. Okay. So for to-do list, one basic item we have is a row of text. So why don't we make something like a title? Let's do our lovely little variable here. We learned before where title equals title. And here text, we just say text title. And click the resume button again, and you'll see our to-do list item on the right. On the left, we have a circle, and when we click on it, it turns into that. How do we want to do that? So first, you see those two align on the same thing. And to place two items on the same line, we use something called an H stack, which means you put something horizontally in a stack. And then we can add something called an image. So that circle on the left, we actually implemented using an image. We tell it to construct using a system name. So here, what we will be using is called SF symbols. There's an app on the Apple's developer website that shows you an entire list of SF symbols you can use. Here, if you just search circle, we can see that there is an empty circle. All right, let's just assume there's empty circle somewhere here.
that is actually going to work. We can see that. So just type circle, and you should be able to see here we have a circle and our to-do list item. Now we should change our image to use based on if the item is selected or is completed. We give a variable. We first make it false. Our to-do list item is now completed when we first write it. So we'll use if it's completed, we will use a different image. I believe there's a check mark dot circle dot fill, and if you click the resume again, of course you'll see that same little empty circle right now because our is completed is false. But when we change that to true, we should see it change to failed demo. We need to click that resume button again. All right, you can see that although a little tiny, we have a little circle there. With that, and why don't we make it larger? If you add the dot right after your image, that modifies your image. We call it to become larger, and your circle just become larger. That's interesting about SwiftUI is you can add modifiers after your things, and they're going to change accordingly. And why don't we add a little tint color to it? So I think it's called foreground color. So this will set the color of your little image. When it's completed, we're gonna make it green. How about that? And if it's not, we'll make it as the same color as all the primary text we have, which is black. So now you see our little symbol becomes green. Great. So now that is a row of our to-do list item. Well, to-do list, there are many to-do list items in there. So what we're going to do is we'll make this to a separate type. In Swift, when you have a data type, it's recommended you call it. You can do a class that's called to-do list item, but I'm not gonna use a class because it's a data type. We should make it struct. So it's struct offers many advantages, and I'll talk about them as we walk through this. And we just copy paste the code we had before in there, and title is something we can change. Is complete is something we can change. Your code doesn't compile right now, but that's totally fine. Actually, we'll declare the type parameter here. Bar is completed. It initially is false. What's going to happen here is we don't have our to-do list item anymore, so we'll have to make an array of to-dos of type and to-do item, array of to-do item. And we set it to an empty list before initially, and then we have. So what we're gonna have is here. This doesn't compile now, but that's totally fine. What we'll have is a list. So a list displays a list of items, and for each items in our to-dos, we're gonna display a row for that. If item is completed, we do that, and we display item's title in the text. Well, this doesn't quite compile yet, because if you want to for each on something, it requires it to be identifiable. So what we're going to do now is we say this is something that's identifiable. For it to be identifiable, you must have an ID. So we're going to say let ID means it's a constant after you make an item. It should be constant, and we say UUID. That way, it just automatically generates a new ID for our to-do list item when we create them. And now, oh yeah, I forgot to add item is completed here. After that, our code should be good enough, and we should be able to see it. Once we resume, we have an empty list because we don't have any to-dos here. But why don't we create some right now? To-do item, we can just pass it title. Oh yeah. Remember that argument label again. Hello. Oh, you need a comma to separate your element in your array. Item title completed. World is true. And now I'm low on power.
we resume. We can see on the right we
have something that's completely broken because I forgot to embed this in an H stack, which put them in the same row. Okay, now we have our working to-do list rows. Yay, not much lines of code. So now the next functionality we want to have is to be able to Alright, let's check off things. You will have UI design. We learned how to modify some views and modifiers. Okay, let's right now add another thing that allows us to add new entries to this list. So here in the list again, after the for each, we're gonna have H stack again because we're gonna have two things in there. One, we're gonna copy this image because remember in our finished app, there is a little symbol in front of the new to-do list item. We don't have an item, we just have a circle in this case. And we also make it large, we make foreground color, I remember is color system gray 3. And we're gonna have another thing called text field. Text field allows users to input some text. And let's see what constructor it has. So we're gonna select the second one. It takes the title. We're just gonna say new to do item. And next is binding. I'm gonna talk about that later. On editing change, we don't care about that. And on commit, when you double click on that, we're gonna see our to-dos should append a new to do item. What's gonna go in there, we're gonna talk about next. So here, there's something interesting called binding. To fill a parameter that requires binding, we're gonna declare a new state by saying add state variable new to do item item title of type string. We're just gonna set it to empty because the new to do list item defaults to empty. And here we're gonna prefix it with a $sign and new to do item title. And here we make a new to do item. Use the same constructor, say new to do item title. So now, try again. Why does this not compile? Huh? Why is this happening? So interesting thing here is we're trying to modify to do, but it's not mutable because it's not part of our state. Now if we mark that as part of our state, this thing should compile perfectly and it should work. Yay, now we can try again. If you click that little triangle button on there, you should be able to interact with your app right now. And you should be able to type something. Hello world there. Oh, we have a bug here. We didn't clear our to do item title to empty. And if we need self in front of it. And if we refresh, there we go. We are now able to add stuff to our list. So that's cool. Now, let's check off more stuff. Stacks identifiable. We kind of have handling events. Let's talk more about that. So here, image. One feature we have is when you click on it, you should be able to toggle. After we set the foreground color, we say on tap gesture. That means whenever we tap it, we can flip the state of it. We're gonna say, this is going to be a little interesting. So to-dos, we cannot just say item dot is completed dot toggle because item is not mutable in this case. Yeah, what we have to do instead is we need to find the index of this thing in the array, and if let's so index ToDos dot index first index of. Oh, you see we have this weird thing here because our thing is not. Swift cannot automatically figure out where our thing is. All we need to do is add an equatable conformance to this, and now Swift is able to just help us find the index of our to-do list item, our little exclamation mark, and to-dos. We pass that index in there, and we set this completed to toggle. So now if this compiles, possibly no, so I just fix it myself. And we try again. And now when we click on those buttons, we should be able to toggle. Great. That's another feature we have implemented. But what's next? So next, we'll embed this into, oh, I can close that now. Next thing we have handle events, animations. Do we have animations right now? Yes, we do. Okay, cool. You see that by adding it to a list, we automatically get the insertion animation there. So that's cool.
What else do we automatically do?
Oh, cool. Let's see. What if we embed it in a thing called navigation view? So just add a navigation view around all of that. In our finished version of our app, there's a huge to-do on top of it. What we're going to do is, where does this thing ends? Okay, if you command click on that, you're going to see where that thing ends. But the one before that, we set its navigation title, bar title, to to-do. And now we get that huge little to-do on top of that. We also have this edit button on top where you can tell it to edit the list. To do that, we just say navigation bar items trailing, because on the right, to be an edit button. And now when you click edit, it doesn't do anything. Why is that the case? Oh, you know why that is the case? Because we didn't tell it how we should edit it. After your for each structure, you can tell it on delete indices. We can delete the item, remove at the first indices we have in there. And we need self. And now if we see this, when we edit, you have this nice little delete on the left, and when you swipe, you get that delete. When you delete, it's deleted. Alright, that's cool. Okay, what's next? So when we see we have delete, the circle is still here, which is kind of annoying. So what we're going to do is to be able to tell our list to hide its image when it's not necessary. What we're going to have to do is declare a new, wait, I think it's called, I think it's state right now, of type edit mode. When we first started, the edit mode starts as inactive because we are not editing our thing. And now we'll pass that to our little HStack, telling it you should have an environment for edit mode to be our edit mode. Yeah. And then we're also going to do the same thing. Why it's not compiling? Self.edit mode. And we're also going to do the same thing. Yes. We need that $sign in front because it requires a binding to our thing for you to be able to change, just like this text field here. When you have a $sign in front of it, it's going to be able to automatically modify your variable as needed. And here, if we say if edit mode is not, actually we cannot do this right now because there's some bug in SwiftUI that requires us to improve our code. So what we're gonna have to do is click on this H stack here, command click on that, and there's a button called extract SubView. So we can help fix SwiftUI's bug for them. We'll call this TODO item row. Oh, okay. Now our thing gets a little interesting and doesn't compile, but that's totally fine. So here we'll declare a thing called edit mode for each of our list item because it's for them. Edit mode, and we're gonna mark it at environment because we're passing in the edit mode environment dot edit mode. So this will serve as our edit mode here. And if our edit mode row value, wrapped value, is not active, we'll display this image. And here it requires us to have a title, so we're gonna say var item here of type TODO item. Now once we have that, we can fix this here by adding our missing item here. Now it's complaining about we don't have a ToDos here. Well, because ToDos are only available in our entire list, what we should do is create a new abstraction around this. So we'll make a new class that handles our TODO items. We'll make it observable object, and we'll make this new ToDos be part of that, but this time we'll make it published. By making it published, we're telling SwiftUI that whenever this array changes, we should update our view. And now we can have a new environment object to be our TODO List store, and we can call it how about database of our type TODO store. And this thing begins with an empty list. Here, I don't think we need that anymore. And now we don't, of course, don't have access to stores directly. We should say database dot TODOs here, and everything should compile except we needed our database here as well. So we're gonna say environment object var TODO store or database of type TODO store, and we're gonna need to replace every TODOs with self.database dot self.database dot. So interesting about environment object is it can be automatically passed down from your parent view in the view hierarchy. Self. Cool. This is compile now. Why does this not compile? Oh, I named this wrong. It should be observable object. And now we need to make this database as well. And this thing should compile as self.database.todos.append. All right, this now compiles. But if you actually resume and preview the code, you'll crash because you don't give it environment object. So what we need to do is provide an environment object of TODO store. This is for our own preview, and this should now be able to preview with an empty list. We're also gonna copy this line of code and open the file called sing delegate and add this to our content view on line 24. And now our app should be able to run and not crash. And if we resume our code, we should be able to interact with our thing as usual with no problem. With no problem. All right. Yeah, it's still working. We can still mark things as completed or not. So we're all good. Now the next thing we want to do is to be able to save our thing on disk so we don't lose our to-do list items when we close the app. And now we're going to do that on this to-do store. So on iOS, there's a data saving strategy called user defaults, which is very good for you to save some simple items. So when we construct this to-do store in Swift, the constructor name is called init. We're gonna load it from user defaults. Oh yeah, we need a parameter for our init. User defaults standard dot let's see what would be the best for this data for key. So because actually when we save it, we want to save it as JSON file encoding to a data, so that's why we're retrieving a data from it. And key is to just identify what our to-do list items are stored as. And if we can find some data from that, this is an optional thing from Swift, and we're gonna set our to-dos to be decoded JSON of type to-do item array from the data we just retrieved. However, this thing doesn't quite compile yet. Swift complains, I don't know how to convert your to-do item to JSON. Well, good question. What we're going to have to do here is just add another interface called codable to our struct to-do item, and this thing should compile. And we need another if let todos equals to try this because of the optional thing we have. Self.todos equals todos. Now this should be able to help us load our data from a disk, and we want to save is whenever our to-dos change, we should save it to disk. We're going to add a braces after our variable declaration, and when somebody set our to-dos, in this did set, we're going to save it to user defaults. So what we're going to do is if let data equals try JSON encoder can encode our to-dos, we'll save it to user defaults. Set our data for the same key you pass in here, so you can find it later. And now, when we preview, I need to resume. So previously, when you review, preview, you always see this empty state. But now, if you type something in there, and you stop, and you start again, you'll see our to-do list items are saved on disk, and you can load them from there. And all the things you have about editing and deleting all still works. Great. Now, lastly, what we're going to have is to have a detail view. In our finished app, when you click on things, you have this nice little enlarged view, especially for you if your to-do list item is very long title. Let's say you don't have the entire width to view that. You can click on the detail. To be able to do that, we're going to embed in this for each in a thing called navigation link. So let's say what constructor it has. We're gonna choose this one with title. No, with this destination label. So when you double click on the label, we can just move our entire, oops, sorry. Actually, we don't want to embed that much. We just want to embed our to-do item row in there. And our destination will be some other things. How about let's just use something we learned before, a text. What's gonna have is the same thing, our text title. And now if we preview our app, if it compiles, you should be able to click on it and you get this text. However, this thing is a little too small. Why don't we make it larger? To change the font size, you just say .font, and I'm gonna say it should be large title. And then when you preview again, it's fairly large. However, this thing is centered. We don't really want to have that. We want to be able to scroll if it's really, really long. So what we can have is have a scroll view. We embed this text in a scroll view. So now we are able to scroll this if it's long enough. Oh, I haven't implemented the edit feature yet, but that's totally fine. And now it's centered. We don't want to have that, so we want to be able to take the entire width as much as possible. We can use this. So what this thing does is it tells it to occupy as much width as possible. We're telling it max width can be infinity. And we'll align this to the left, which is leading. Now you say it's aligned to the left. However, that doesn't look quite nice, so we'll add a little padding to our text. And if we refresh, we see this has a little nice padding here. And we don't really have a navigation title here. That doesn't look nice either. So we'll tell it to have a navigation title. Details. Alright, when you have that, you have a detail of your thing. And that's a very basic to-do list app we have right now. I think due to time constraint, I'm gonna stop us here. Does anybody have any questions I can quickly answer before I move on? Alright. So I think we learned how we can create views like text. We can modify it with these modifiers, like we can change its font, we can change its frame, we can add a little padding to it. And we have this environment object which allows you to pass down your database without necessarily doing it in your constructor. It gets automatically available to your views that declare it as dependency. We have navigations. We don't have time to cover alert, but that's something you can also do by just adding another modifier that says .alert. And you can experiment with that yourself. That's available. We know how to store stuff onto your disk using user defaults. We don't have time to cover pasteboard, but that's available in the final version of this app. But here, before we end this thing, let me show you one more thing we can do with this. Open this blue little icon here. So right now we are almost always running this on our iPhone. What we're gonna have to do is click this Mac button here, and we say enable. Now we can say we can run this app on our Mac, and I need to sign this with my developer account. And it's gonna be building, and we will hopefully. Why don't we also run this on iPhone simulator? We got our to-do list app on a Mac. At the same time, we are writing a Swift application for iOS. So that's something cool thing you can do with SwiftUI is you can have to-do list app on both your iPhone and Mac with the single code base you have. And actually you can see this to-do list app I'm using the entire time is actually the same way you just wrote. And now let's move on to the next thing. Actually, someone open sourced a project called Swift WebUI, that allows you to take the same code base and develop it as a web app. So that basically means if you know Swift and SwiftUI, you can develop for as many platforms as you wish, as long as it's supported. And should we still call ours Mobile Development Club right now, if we can make so many things?
Maybe.
Well, maybe. So if you want to have this final version of our code, it's available at GitHub.
You uploaded this project.
Yes,
it's a public repository.
Yes, it's on github.com/uw-appdev/ I don't remember what's
the. In our club public repository.
Yes.
Oh.
So if you go to GitHub and uw-appdev, you can find the complete version of this to-do list app here. It's basically the same thing we wrote, but with a little more features like editing and copying to pasteboard and stuff. All right. And for that, if you want to learn more about Swift, there's a Swift programming language ebook and website you can look for. There's official SwiftUI tutorial and WWDC sessions you can check on Apple's developer website. There are paid and free online courses teaching you more stuff with iOS development, such as Stanford CS1 S3P. And you can join us if you want to actually be able to learn all of this at a better paced style, and we can work on this together. So I guess for that, thank you for attending this workshop. And all right, any questions?